several months ago, we looked at this type of chart, and what did I call it? Remember this two-way table? There was another word for it. Contingency table, right? And a contingency table deals with two different variables, and they're usually qualitative variables. They're usually counts. So I have gender, you're either a boy or a girl, and I have goals. The goal to be, have good grades, the goal to be popular, or the goal to play sports. Whenever we have a contingency table, you really want to make sure that we're looking at totals. Those totals should be there because often they're useful in finding probabilities. These are the numbers we're going to be dividing by. Okay? They'll be in the denominator of my fraction. So let's remind ourselves and ask a couple of questions. What's the probability of selecting a girl? What numbers am I looking at here? Yeah, so I'm looking at the total of girls, and I'm going to divide that by 478. Okay? And right now, I'm going to tell you, I always want to see what you divide by. Always. So don't just give me the decimal. I need to know how you got it. Okay? It's okay to do both, but for now, we're just going to look here. Go ahead and tell me what 251 divided by 478 is. I don't have it in my head. I'm not that smart. Human calculator is not me. 0.5251? I would agree with that. That's a nice place to round as well. Okay? I agree. All right, how about number 2? I'm just going to erase the highlighted stuff in my contingency table just so it doesn't confuse us. What's the probability of selecting a student with the goal to be popular? So I'm looking at popular now. We're looking at just a random student with the goal to be popular. Is now going to be 141 divided by 478. I agree. What's that probability approximately? Wait, what? 295? You all agree, rounding-wise? Looks good? Okay. What's the difference about what we've seen so far and number 3? It's a key word. And. Now, when we talked about and before, we were looking at multiplying. It's a little bit different when we have a contingency table. Where am I looking for the word and? In the margins, on the total column, or am I looking in the middle? In the middle, because I'm looking for it to be both variables. So a student is a girl and popular. Girl and popular is this number. Would you agree? So what's that probability? 91 divided by 478. I agree. What is that? 19 what? 03? 04? Probably should go out to that point, okay? I would probably accept 0.19, but I'm just telling you, you want to go out as far as you can because you don't want to get really close probabilities. If it says student, what's the probability of selecting a student? Any student. We're going to look in a couple of minutes of when we divide by other numbers. So maybe that'll be clear. Right now, all of things are divided by 478. In a few minutes, they won't be. Okay? So hold on to that question. So let's look at question 4, and then we'll look at Angelica's situation. What's wrong with using our multiplication rule? By the way, multiplication means one and the other. I can just multiply, right? So let's put this in context here. Number 3 says the probability is girl and popular. The rule that we know so far means I just take the probability of girl times the probability of popular, right? Okay, so probability according to my contingency table of girl and popular is 0.1904. Would you agree? Probability of girl was 0.5251. And the probability of popular was 0.295. Can someone multiply those two together on the right-hand side for me? What do you get there? Do you get 0.1904? You do not. That's an issue. What do you get? 0.1549? They are not the same thing. That means we can't use this rule. Any ideas as to why you think they might not be? Think about just the context of the problem. Why might this not work? When can't we use this? Ms. Macker, you said and means multiply. Well, only if they are independent events. If this is true, you take the and, you multiply, and they don't match, that means these events are dependent on one another. Being a girl and wanting to be popular are dependent events. Okay? So that's what that shows. Mathematically, that's what that shows. Okay? So if you have dependent events, you can't just use the multiplication rule. That's important. I write that down. This last one right here. Just to show you an example of, because it's going to come up. Are two events independent of each other? Here's an example of when they would be dependent. What formula am I using? I'm using the multiplication rule. Girl and popular, by rule, just means girl times popular. If they don't equal each other, then that means they're not independent. They're dependent. If they do equal each other, what does that mean? If those two sides, left equaled right, we could say they're independent. And you want to write it in context. You want to say that girl and wanting to be popular, we'll say goal, I think I said it this way, goal of being popular is dependent on gender. Okay? Question in just a few minutes, unless it's an emergency. Is it an emergency? If you can wait a couple minutes. Okay? All right, let's look at some. Angelica had some great questions. When do I know what to divide by, and why were these all divided by 478? Let's look at some where that's not going to happen necessarily. Okay? So, number one. Same data. Probability, select the student as a boy and has a sports goal. The keyword and means I'm looking where? The middle of the table. So find your intersection of your row and your column, the boy and sports. What number are you looking at? 60. Am I still dividing by 478? It just said selected student, just some random student. So far, yes. And again, you can reduce that if you want. Okay? Number two, boy or has sports as a goal. Okay? I use the or formula. So let's put this, and you should probably write this in context too. So probability of boy or sports. It's a bus. Whenever you use this formula, I am looking that you write the formula in context. Please don't write A's and B's here. Please write boy and sports. Like, use the letters so I know that you know what we're talking about. So what's the formula going to be? Probability of what? You have your addition formula on a formula sheet somewhere? Hopefully. Get it out if you don't. Corinne's got hers. Is yours in here somewhere? James? Oh, fire today. Katie, what would I say? Probability of what? Boy. Plus probability of sports minus the probability of boy and sports. That's the formula in context. Let's put the numbers inside there now. Okay? What's the probability that they're a boy? Boy would be 227 out of 478. Plus probability of sports, 90 out of 478. minus 60 out of 478. Isn't that where the and is, for the two intersect? They're all over the same denominator, so I can just simply combine the numerators. 27 plus 90 minus 60 looks like it's 257, right? And you can reduce that or write it as a whatever. Now, number 3 is different. We had an and in the first question. We had an or in the second question. What's the weird phrase or the key phrase in the third question? The given. And remember, I told you strategy-wise, that was the one at the bottom I hadn't talked about yet. So this is some key situations. That tells me I'm dividing by something different. And I'm no longer dividing by 478. I'll tell you what in just a minute. Good question? Okay, so let's pull that chart back up and let's figure out what we're dividing by. Whatever follows the word given that is what you divide by, okay? So we're given that they are a boy. So I'm going to be dividing by 227 because that's the total of the boys, okay? So dividing by 227. I'm actually going to be looking at this 227 row. I'm looking at this boy column. I'm sorry, this boy row. Okay? The boy. It said boy, right? Given that they're a boy, right? So now I want to figure out what goes in my numerator. Well, the probability of a selected student has sports as a goal. So I'm only looking in that row. So what number? 60. Perfect. So this is just 60. 60 divided by 227. Okay? So when you have the word given or given that in a contingency table problem, we're able to use that to answer questions and tells us where we're going to go and what we're going to do. Okay? So I have another one that I'd like us to look at, and I'm going to have you guys randomly come up. I'm going to let Cameron go to the potty, and then we're going to all kind of look at these next 6 questions. Okay? Different questions. We have different things to add, subtract. We have a different contingency table. These are just some counts of males and females in the different classes in a high school. How many students are at this high school? 1,284. It's a tiny little school, isn't it? That's like the size of my kid's middle school, right? It's tiny. This school has almost like 2,400, twice as big, I think. All right, so anyway, so you can come up yourself, or I'll pick you. Who wants to do one? Byron, 1. Who wants to do 2? I'm going to pause this. No one wants to hear this. So far, as I'm looking at the answers, I only see number 4 in context. Extra points, gold star, amazing, woohoo, bring it up, raise the roof, awesome, okay? That's what I'm looking for. Show me what you're doing. Nobody else done that? Well, you should have done it in 2, 3, and 4. The ors matter, because you have to use a formula for or, don't you? You have to subtract off the intersection, unless it's a Venn diagram. The Venn diagram, you've already done the subtraction, but you have not done any subtraction in a contingency table yet. So you have to use the formula, okay? That's key. So we'll come back to that in a few minutes. So number 1, freshman and female. The and in a contingency table means I can just look inside, right? So freshman and female, we have 172 out of 1284. Awesome. Check. I agree with number 1. I'm not checking the dividing part. I'm just checking the fraction part. Okay? What's the issue with number 2? Let me show you what the issue is. I'm going to try to do it visually, not with crayons. All right, highlighters. Freshmen and females. What did I count twice? The 172 got counted twice, didn't it? That's an issue. So I've got to subtract it off. In a contingency table, you haven't done any subtracting yet. The Venn diagram, you did. Okay? So we have to worry about that. So in order to make this more correct, we have to subtract off the 172. Okay? So I have 300 plus 704 minus 172, all over 1284. I can't do that in my head. I wish I could. Maddie, I'm stealing your calculator. Thank you, thank you. So I have 300 plus 704 minus 172. I get 832 divided by 1284. Does that look right? Okay. How about numbers 3? I'm not sure what that says. Help me. Oh, they added the 398 and the 338. Same issue with number 3. Wouldn't you agree? So we have junior or senior. So I'm going to highlight those. So I have junior or senior. Wait a minute. Do they overlap? Is there any intersection or anything that's counted twice here? There's nothing to subtract. Would you agree? So this one is actually correct. Number 3 is correct. There is nothing to subtract off. You just have to add the 398 and the 338. You're good. Only when the contingency table does this do you have to subtract it off. Okay? With the word or. How about number 4? She's done all the work for us. She wrote it out in context. Probability of senior plus the probability of male minus the probability of senior and male. I can only hope that she didn't show the dividing part's the only thing I'm worried about, okay? So I would like for you to show me what you divided by to get there rather than show these as decimals, write them as fractions, okay? Would you do that for me from now on? Okay. Can we go back and just do that real quick? Sure. Okay. That's fun. I'm assuming we'll get the same answer. So we have senior, right? Yep. Senior is 338 out of 1284. Male would be 580 out of 1284. And then the intersection would be 154 out of 1284. And that would give me enough context, fractions, final answer. Okay? I'm looking for all of that, by the way. All right, what do you think about number 5? Oh, I have a problem with number 5. Why? Do you see the mistake? Given that they are male means this denominator should be the total of the males. It's not. So what should we change that number to? 580. That's the total of the males, right? The numerator is a senior, so it's going to be 154. So I agree with the numerator, but the denominator should be 580. Not 580. Good. Can someone tell me divide that for me? What do you get? 154 divided by 580. Calculator wise. 0.2655. What's the problem with number 6? Same thing. Denominator's wrong. What should the denominator be in number 6? Juniors. So let's look back up here, because given that they're a junior, so it should be 398. So the denominator here should be 398. What's the numerator? What's in the numerator? 226. Angelica's on fire. Okay. Make sure you understand what goes where. Are we okay with why the denominators had to change for 5 and 6? So we're given that, right? Okay, perfect. What I'm going to have us do, well, yeah, I guess we should do this. On your formula sheet, do me a favor. Go ahead and take it out if you haven't already. At least look on with someone if you don't have yours. And I want you to look at the second formula in the probability column. Okay? Second formula. Tell me what you notice with the one that's on the board. Compare it to the one that's on the board. A line. By the way, that line implies the way that's read is B given A. The given that. The given is that line. So we saw it in words before. This is what it is in formula form, okay? Your formula looks a little bit different than the one here at the bottom. Let's just worry about the one here at the bottom, okay? What's different about the one on your formula sheet versus the one that you see here? Okay? It starts off as A given B. Do you agree? That's the one your formula says. And the formula on your formula sheet, it says that the numerator is the same, but this time the denominator is the probability of B. It is okay to write it either way. What's important is the given that, remember this is read A given B, what follows the given that is always what you divide by. Didn't we? What follows the given that is always what you divide by. We did that in the contingency table, didn't we? We're going to do that here in the formula as well. Okay? So you can write it any way you want. It's just that you can contextually put whatever you want to it. Just remember, what follows the given that is what you divide by. Okay? All right. Let's look at some problems where that's going to happen. What I'd like us to do is I'm going to hand some problems out to you. If you look at problem number 1 on the back, you have a what? You have a contingency table, a two-way table. What is different about the two-way table that is here versus the one that we did a little while ago? There's no totals. So let's go ahead and add both a row and a column for the totals. Give me something else that's different about this contingency table versus the one that we did before. I see decimals or probabilities in this contingency table, whereas the other one was counts. Wouldn't you agree? Where I had to divide by something to get the probability. I don't have to do any division here. It's kind of the probabilities are already there for me. Since we're talking about probabilities here, what should they all add up to be? The total here should be what? 1. If it's a probability situation, correct? They should all add to be 1. Double check that they do. They should. Do they? Good. They should. They should. Okay. So let's go through and ask ourselves a series of questions. Letter A says, what's the probability of rain? .36. It's just that we don't have to divide by anything because it's already given to us. We don't have to divide by 1. We could if you wanted, but really not necessary. How about B? What is the probability of accident? 0.04. Very good. What is the probability of accident given that it's raining? I'm going to put R here just for rain, but it's the same thing. They wrote it as B here. I always like to put the letter so it helps me. And it even gives you the formula. Aren't they nice? I almost never will do that. You'll have to know to do that yourself. It's on your formula sheet, okay? So it's just the probability of accident and raining divided by the probability of raining. So accident and raining, where is that in the contingency table? The and is always in the inside, so accident and raining is going to be 0.025. What's the probability of rain? 0.36. Divide those. What's the probability of accident given that it's raining? Double check her. I don't trust Katie's calculator. It might lie. It's never a calculator issue. Double check it though. She might have fast fingers. You good? That's right. All right. All right, D. What is the probability, by the way, this is a typo. What is the probability of an accident if it is not raining? This one, to me, has no keywords in it. It doesn't have any ors, ands, or givens. But I can rewrite the sentence so it has a keyword in it. So I want you to think about it. First of all, you're looking for keywords. If you don't see them, you need to ask yourself, can I reword the sentence so that it doesn't change its meaning, but it has one of the keywords in it? Can you? You can. How would I do it? So you should write this underneath it. We're looking for the probability of accident given that it's not raining. We'll write it that way. I'm a squiggle person. You can rewrite this with a given that in there. Not and, but it's a given that. It takes a little bit of practice to get to know whether it's an and or a conditional. And we'll work on that some on Thursday. Okay? So how do I do that here? Well, accident and rain divided by, sorry, accident and no rain, right? So 0.015 divided by 0.64. Oh, I didn't write that down right. It's 0.015, right? Notice what's important here. The given that is the no rain. So we're looking at this column, which means all of the numbers should come from that column. The denominator is in the total of that column, and then I'm looking at the not rain, so that's my numerator. If that helps you, then go ahead and highlight it. They do make erasable highlighters. I own them. They're so fun. Sorry. Anyway, they're cool. If you want, I'll give you one. Come see me in my office. But 0.015 divided by 0.0234. Okay, I agree. What about that last question? The last question of the day. What does it say? Like, see, read it to us. It's exciting. What do you think? No. 0 credit. Yes, 0 credit. Please, in this situation, do not say something. I mean, intuitively, we know that there's more accidents when it's raining out. I agree with you, okay? But what I'm going to say to you is, where's the math? Don't write me a sentence saying yes and give me some, hypothetical, when I drive, I see more accidents in the rain, therefore it must be true. I deem it so. Okay? That's great, but I'm going to say it's a math class. Where's the math? And so you should say, star this problem on your paper. If you see the word, is it independent, you need to say, where's the math? Où est la math? Okay? Let's say the French. Où est la mathématique? I don't even know what I'm saying. French? Hello? I'm close. Thanks, Elena, for at least pretending that I'm sort of close. I took 6 years of French. Embarrassing, eh? Okay. Here we go. So, is it independent? There are two, there's really more than two, but we're going to look at two different ways to show this. Where is the math? I showed you earlier that you could say, is rain and, what is it? Rain and accidents, right? Is that just the probability of rain times the probability of accident? Remember how we talked about that earlier today? I said, can you just multiply? Does the multiplication rule apply? What's the probability of rain and accident? Rain and accident is 0.025. Do you agree? So 0.0, this is what you should write this down, 100%. This is going to happen, going to show up on your test or your quiz next week, 100%, guaranteed. You will answer this question. What's the probability of rain? Looking back up here, probability of rain is 0.36. What's the probability of accident? No. 0.04. Can't read your own writing. Embarrassing. Just playing. Multiply them. What's 0.36 times 0.04? Is it 0.025? Nope. What is it? 0.0144? Which is not equal to 0.025. They are not the same thing. That's your math. You have shown, therefore, back to geometry. Remember the 3 dots? Therefore, you didn't have me. All right, so therefore, we're going to say that rain and having an accident are not, you can say either not independent or you can say the word dependent. It's fine. I'll accept either. If you're asked this question, this is a lot of work. Do not say, well, when I drive down the road, it seems as though there seems to be a lot of accidents when it's raining because the tire doesn't engage with the road and there's a water. Don't tell me that. You lose traction. And great. That's probably true, but where's the math? Okay? This question requires math. Remember how there's 2 ways to do it? You do not have to do both. But I will show you the other way if you're interested. Because sometimes, and we'll look at situations like this next class, you can't use this formula. In this instance, you can use either one because you have a contingency table. You're not always given a contingency table. Okay? The other way you could do it is this. The probability of accident given rain is the same as the probability of accident. The conditional probability is the same as just the regular old probability itself. Okay? If that's true, then they are independent. If they're not the same, they are dependent. So you may do it one or the other way. You don't have to do both. So A given rain. Accident given rain. We're now looking at this row, given rain. Would you agree? So we're looking at this one, this column, sorry. So accident given rain. So we're looking at 0.025 divided by 0.36. Would you agree? I don't know what that is, by the way. Again, just accident given rain. Remember what given that is what you divide by. Okay? What is 0.025 divided by 0.36? 0.036. Is it 0.36 or 0.036? Oh, well, you were right. I was wrong. What'd you get, sweetie? 0.094. Okay. Oh, wrong thing. I wrote on got to write on the left. How about the right? What's the probability of just a plain old accident? Plain old accident is 0.04. Is that the same thing as 0.094? Are they the same thing? Did y'all get something different over here on the left? Y'all are all like, tell me, speak up. I don't have a calculator in front of me. Okay, it's 0.0694. Speak up. Thank you. They still don't equal each other. Would you agree? They're still not the same. So therefore, the same conclusion holds true. Therefore, having an accident and it raining are dependent events. Okay? Again, either or would answer that sufficiently mathematically, because I will ask you the question, where's the math? So what's your homework? If you flip it over, you have part of your homework. Your homework is going to be to do problems 3 and 4, okay, on the conditional probability handout. Yes, there is. It's the bottom. Oh, I'm a liar. It's 2 and 3. I think in your text you're going to get it 210. It says 3 and 4. You know it's just the other 2 problems. It's 2 and 3. Okay. You also have something else. You have 8 problems on a separate handout called General Probability Rules. You're to do problems 1 through 8 here. I am going to give you a I'm going to give you a hint on these. Remember, you're looking for strategies, right? You're looking at what strategy am I using? When am I adding? When am I subtracting? When am I using formulas? When am I using Venn diagrams? When am I using contingency tables? I want you to search on here and look and tell me where you see a contingency table on this entire worksheet that I handed you. Nowhere. Guess what? You need to do one. Your hint is you should create a contingency table for number 6. Okay? So number 6, create a contingency table. That will help you answer the questions. Okay? So that's your hint on number 6. This will be due on Thursday. We have a little bit more to add with conditional probabilities on Thursday, and then you have a quiz on Monday that's covered everything we've done so far in probability. It's a lot.